Good morning, everybody. My name is Sarah. This is Bryan. These are Twitter handles, and that's also my GitHub. And we are core developers of Bokeh. Oh, there we go. We're split over lunch today, and so this morning, the first hour before lunch, we're going to do a kind of whirlwind tour of Bokeh and just kind of throw a lot of information at you. And then we'll have lunch, and then after lunch, hopefully not too much of a food coma, we'll get really down in the details and have you all trying it out, and hopefully, really getting a handle on it. Bokeh has grown to be quite a large project, and so we really want to kind of give you a flavor of all of the kind of things that it can do, because there are lots of different ways you may want to use Bokeh depending on what kind of a user you are. Are you an analyst? Are you a developer? Are you making, public-facing dashboards, or are you doing, data analysis in the notebook and everything in between? And so we're just going to try and give you that big picture this morning. Feel free to interrupt us at any point and ask questions. That's totally fine. So what is Bokeh? Really excited to see some of you already using it. It's a data visualization library. It makes web-based interactive graphics. That's its real stronghold. But with no JavaScript required. I come from a web developer background, but even though I can write JavaScript, I don't love it. And so the opportunity to write things that run on the web in Python or R or other languages is really exciting. Also, one sort of distinguishing feature is it can handle both large and very large data sets. If you're working with something like D3 or any kind of SVG-based thing, you may find that if you start to interact with more than 1,000 points, like your web browser starts to implode. With Bokeh, you can comfortably handle tens of thousands of points, and we'll see some examples of that today. And it's also really good at streaming data and making your Python code come to life and your data come to life with Python. So the core things that we're hoping that you'll take away from today is to have that big picture feeling of all the things that Bokeh can do, to know where you want to come into Bokeh at the charts interface or the plotting interface, and what those two different things do. The Bokeh server, what it is, what it isn't, do you need it or not, how to use it and how to share your work, and awareness of the larger Bokeh ecosystem. So I'm going to hand over to Bryan, who's going to get us started with some demos to kind of set the scene before we dive into a bit more detail.
Hi, good afternoon, everyone. So as Sarah mentioned, over the last few years, Bokeh has grown to be a pretty large library. So yeah, we just want to start off by giving you just the lay of the land, sort of some of the things that are available. And so right now, we're just going to show some things that are very easy to get started and that you could do today. So the first thing I want to show is one of the APIs in Bokeh, and Sarah's going to talk a lot about this in more detail afterwards, but one of the ones we want to talk about is the Charts API. So there's this level of Bokeh.charts, which is really a very high-level interface for creating sort of standard statistical charts with a minimum of code. So it handles the standard use cases in a line of code or one-liners, two-liners of code. In this case, if you want a box plot, that sort of thing is built in with scatters or box plots. And so let me go ahead and open up an Jupyter notebook, and we can take a look at some examples. The one that I want to show is this one. Right, so I just want to go through some code. Let me go ahead and make the font here a little bit bigger. So first off, the one thing to mention, of course, is that Bokeh works really well in the Jupyter Notebook, right? So a lot of us, if we're using sort of the PyData stack, we're probably familiar with the Jupyter Notebook. If you're not familiar, Jupyter Notebook's a great open source project that basically brings Python into a notebook type interface into the browser. It's really great for sort of exploratory data analysis. A lot of interesting things happening in this space too as well. Yes, question? This particular one is in the repo, yes. So there's a Bokeh-demos repo, and we'll actually have a link to that later in the slides. But if it's on GitHub under the Bokeh organization, under Bokeh-demos, and it's in the master branch under presentations. But we'll have a link to that later too. So the Jupyter Notebook is really great. There's actually a lot of exciting work going on with the notebook to make it really suitable for other purposes too, sort of publishing and reporting. And so just really exciting to see the development of the notebook over the last few years. But anyway, Bokeh works really well in it. So in this case, for instance, we want to have like a scatter plot. It's really easy. We can load our data in a data frame. Hopefully we saw the last tutorial. We know a lot about data frames now. Really great data structure for representing and munging data in Python. And we can pass it to scatter. And we get a nice scatter chart that's faceted by, in this case, the number of cylinders. And we have a nice legend. And we didn't have to do too much work to get that. So one of the core ideas of Bokeh is that we really have a wide range of capability and expressive nature. And the charts is really at the top of that. It's how to we get the most work done sort of in the least amount of work for you. when you're writing code. Other types of charts here, bar chart. In this case, we can have stacked or grouped charts. Really easy to go through. Let me actually execute some of the cells in this notebook.
Was it different than matplotlib, something like that? The same?
So the question is about if this is different than matplotlib. So one of the things that's different from this from matplotlib is, for instance, that all Bokeh charts, they're really geared towards the browser, and they have lots of kinds of tools. So you can have things like panning, resizing the chart. You can have selections and zoom. All of these tools work natively in standalone Bokeh plots, but also we'll see in a bit we can use the Bokeh server to have really rich interactions that are driven by, for instance, Python code. So we'll get to that in a bit. Here, for instance, we have a bar chart. And it's stacked, but it's really easy. We could use a different kind of grouping here. We can say group. Sarah will get into some of the details of this, but it's really easy to change this sort of thing. So really, the idea is to have a very high-level interface for sort of one-liners. Other charts that are built in, histograms. If you want to facet by one of the columns in your data frame, it's easy to do that and get out multiple histograms. Box plot in this case, box and whiskers plot for showing different distributions. Very easy to get through. Heat maps as well. So here again, we just have the auto MPG sort of cars data set, and we can show the displacement versus the miles per gallon as a heat map as well. And then last one, let's see here, postage rates. We have a nice step chart. So there's other charts that are built in. Sarah's going to get into a bit more detail, but just wanted to really convey the main idea that these kinds of high-level charts, when you're doing sort of exploratory data analysis, when you're in the notebook, it's really easy to get these kind of simple charts out, which is a very minimum of work. Okay, so that is the charts sort of demo. The next thing I want to show off, just to make people familiar with it if they haven't seen it, is the Bokeh server, and to show an example of the Bokeh server. So we have a very new Bokeh server as of sort of the beginning of this year. It's much, much improved, much easier to use, much easier to deploy. And so I wanted to show a quick example. And the main use case of the server is really if you want to run Python code, for instance, things like, in this case, a machine learning algorithm driven by a web interaction. So let me go ahead and load that up as well. So that one's actually already running. Start it. So there we go. So we have a nice application in the web. We have some sliders here, some drop downs, and we can interact with this, right? So here I can change the number of sample points that I've got. I can change the number of clusters that I want to see. And what happens when I drive these interactions, scrubbing the slider, or if I want to move to a different data set, what's happening is that it's actually triggering Python code to get called. So in this case, it's calling out to scikit-learn to do different kinds of algorithms on different data sets. Here we can select, see what spectral clustering looks like, and we can sort of see that really easily. So what does the code for that look like? That's sort of maybe the most important next question is how difficult is it to make things like this? And the idea is that we make it very simple. So we'll dive into a bit more details about some of the server examples later, sort of a full walkthrough, but just for now, a flavor of what that looks like is we have an update samples or data set that gets triggered whenever someone scrubs the slider, for instance. So here it picks the algorithm, it picks the data set that we want. It calls out to scikit-learn to do the clustering, and then it updates the data for the plot. And so the main point of the server is to be able to have this automatic, transparent two-way connection between Python and JavaScript. So you can have these deployable web applications without having to really write a lot of code to do it. Okay. So that's one example. Another server example, Sarah mentioned streaming. I just wanted to show this one off right quick as well. There's a nice API for streaming data, which we're continuously improving. We're going to be adding some more capability to that soon, but just as a quick sort of look at what that looks like, I can run this OHLC demo here as well. Let me stop the other server. OHLC stands for Open, High, Low, Close. It's a sort of standard kind of financial chart that shows stock prices where they close in a given day. At the bottom, we have another kind of chart. It's called a MACD indicator. I'm actually not a quant finance guy, so I don't know too much about it. But what I can say about this example, well, I don't know. Actually, first of all, if you wanted to have this kind of example running sort of streaming data into the web, have these nice controls. Here we can change the standard deviation. We can change to a different type of EMA. I don't know, show of hands, how many lines of code would you expect to have to write to get this? One? Okay, well, I can't promise you that. But this code, including the simulation, right? All the code to actually generate, so this is simulated synthetic data. All the code to generate the simulation, all the code to compute the MACD indicator, all the code to create the plots, the widgets, and tile the callbacks is under 100 lines of code of Python, right? And again, most of that is actually the simulated data. So if you were actually reading the data from some other source, the actual code to create the charts and the callbacks is actually a really smaller fraction of even that. So that's the main idea there, is we want to make it very easy and efficient to stream data. Okay. And I think last but not least, want to say a few things about Datashader. So Datashader is actually not part of the Bokeh core project, but it's under the Bokeh organization on GitHub. It's really, its goals are to be able to handle large data sets in a meaningful way. If you have, thousands of points, tens of thousands of points, you might decide that you want to actually plot those in the browser. Once you start getting to hundreds of thousands, millions, hundreds of millions of points, obviously you don't want to send those in the browser for reasons that your browser will fall over, but also once you get to that many points, you really have to start taking care that you're making sort of a useful visualization. You want to make sure you're making a visualization that's actually meaningful, that tells you something, it's not lying to you. And if you've got that many points, you start to run into problems like overplotting and underplotting, and what do you do about those? And so Datashader is an attempt to sort of meaningfully handle those kind of things. So let me show a quick example of that as well. So again, this is a separate library, but it integrates very well with Bokeh. It's on GitHub under Bokeh-Datashader. It's also open source library. Here's an example using the New York City taxi data set. So this is 12 million points. And the kinds of things you can get and the interactions you can get with Bokeh are, for instance, it's really like a visual query system, right? So actually what you can do is you can say things like, I want to see where there are more drop-offs than pickups on this 12 million point data set. And you can query the data set and have that show up. And here you can see, probably makes sense, there's more pickups along the sort of the big north-south avenues and more drop-offs on the side streets. But what's nice is that you can use Bokeh's interactive capabilities combined with Datashader to really zoom in. So here, for instance, if I zoom in near LaGuardia, you can actually see all this sort of fine structure. And that's progressive refinement. That's actually doing this update on that data set on my laptop. We've demonstrated Datashader on much larger data sets. Go over here to notebooks. Actually, there's a link to this in there as well, to the OSM data set. That's actually a 3 billion point data set. And one of the nice things about Datashader is the way it's architected is you can actually do things out of core. If you don't have enough RAM to do it, you could actually process that entire data set on, for instance, a laptop. And Jim has done that just as a demonstration. But if you have the RAM, which increasingly is the case these days, you can actually use Datashader very efficiently. I think it took something like 7 seconds to process the 3 billion points and get the images in this OSM example. So anyway, the Datashader is really cool. It's a new project. It's a lot of under active and heavy development right now, but definitely looking for people to try it out, and we'll talk a bit more about it later. So I think that was all the demos. So I'm going to turn it back over to Sarah, talk a bit more, and then we'll pick things up again.
All right, so once again, core concept today, overview of Bokeh's functionality. Hopefully you've just got a little flavor of what we can do. And now we're going to sort of dive a little bit deeper into navigating Bokeh's interfaces. First, I want to remember to thank NumFocus. They organize all these PyData events. We're hoping to become a sponsored project this year, and they do an amazing amount of work in the community, in the PyData community, so we really appreciate them. So Bokeh Core is this Python-based library that gives you the charts interface that Bryan showed you a little of, these sort of one-liners that sort of work out the books. It lets you also create completely custom plots. Anything you could think of, you should be able to make by piecing together all of the shapes and circles and whatever that you want to. So you can create very, very novel graphics. The interactions also come out of the box. So not only can you create completely novel graphics, but you can create completely interactive novel graphics, styled into however you need. And then you have this feature of the server where you can hook very, very seamlessly between your web client front end and your Python backend, and just get this amazingly powerful interactivity, not just what your web browser can do, but anything you can handle. Yes?
Do you use Bokeh inside Spark Zeppelin notebook?
So the question was if you can use Bokeh in a Zeppelin notebook, and I believe, so we haven't done any active work on that. I've seen that question come up, and I believe someone might have made that work, but we'd have to go double check. It was someone outside, some interested user, and I believe they did get some kind of integration working, but we'd have to go sort of look and try to dig that thread up or that message up. But people are interested in that, and so we're always interested in increasing the number of integrations that Bokeh has. Actually, it might be good to mention at this point, Bokeh also works with languages like R and Scala, right?
Yeah.
Oh, sorry.
The next slide right there is that there's a wider Bokeh ecosystem. So when you sort of download Bokeh, when you go to GitHub Bokeh/Bokeh, this is what you get. But the Bokeh ecosystem is a wider thing, and so there are actively maintained R Bokeh, so an R binding, a Scala binding, a TypeScript binding. So all of the things that you're going to see spelt here today and described in Python, you should be able to do in these other languages too, if you have other languages in your business or organization. In addition, you have things like Datashader, and which is a sort of separate project, but it's leveraging Bokeh, but doing lots of other interesting, powerful things. And then we'll probably not get to this today, but Bokeh we've been building in the functionality to make Bokeh really extensible. So if something isn't built in the box, you can write your own kind of custom reusable little pieces of widgets or code that let you do the custom chart, do the out-of-the-box thing. So somebody only has to write it once, and then everybody can reuse it. And we're making that easier all the time. And we do have an active mailing list and a community around Bokeh that sort of share and help and support each other, both on the Google group and on Stack Overflow. So interfaces. Let's get to some meat. So there's three interfaces. There's three main interfaces to Bokeh, and this can be one of the things that I think people new to Bokeh find a little bit confusing. Hopefully, we'll demystify that today. There's charts, plotting, and models. And so charts is this sort of high-speed approach. We've tried to choose everything for you and do the right thing. Then there's plotting, which gives you a whole bunch more flexibility, but you have to do a little bit more work, and that's more kind of sensible defaults kind of approach. And then there's models at the lowest level, which with the Bokeh models, you can build up absolutely anything you want to. Now, Bokeh plotting is built up of Bokeh models, and Bokeh charts is built up of Bokeh models. So these are all the same things. They're just kind of layered interfaces on top of each other. And so hopefully this will continue to make more sense. So once again, Bokeh charts gives you that high-speed one line. It processes your data and it spits out a chart. Bokeh plotting tries to pick sensible defaults. You have to get your data sorted, and hopefully it'll do a decent job of organizing your plot for you. And Bokeh models, which we're not going to talk about today, it's a bit of, when you get into it, it should be obvious, but it's the lowest level. It offers you the most control, but you do have to do all the work yourself. So the charts. There are 12 charts built into Bokeh at the moment. There's also documentation about how you could build your own one, your own sort of whatever chart that you need. Wherever possible, the interface is designed to be simple to use with pandas. So everything you learned this morning about how to use pandas, how to get your data to do what it wants, that's sort of the prep work to sort of just throw it into your charts and really, the charts is very much aimed with the sort of exploratory data analysis kind of in mind. There is both a user guide page and a reference page in the Bokeh documentation, which we'll be touching on today, that I would point you to and highly recommend that you check out whenever you have a question. So let's go and just have a little bit more detail about what it looks like when, I did not mean to do that, excuse me. What it looks like when you want to start messing around with charts. So you import pandas, which hopefully you saw this morning. Let's make this a bit bigger. The next thing is sort of a piece of Bokeh administration, which you're going to have at the top of all of your notebooks, is from bokeh.io. You're going to import the output notebook and show, which are fairly self-explanatory. You load output notebook once at the top, you get this nice message that says, we've loaded Bokeh, and now you can start playing. So there's some sample data sort of that's built into the Bokeh library that we'll play a bit with today. Maybe you have some of your own data that you want to play with. But here's a data frame with some just a whole bunch of cars in it. And here's a data set with some glucose, sort of a time series with some glucose readings in. So I'm just going to import all of the charts for ease, but let's get into it. So scatter, it's pretty much as simple as it can get. Let's put miles per gallon on the X and horsepower on the Y, and have a look. And so as we can see, we've got these tools like Bryan already mentioned, sort of built in. And what I've done is I've set some global defaults. I should have restarted this this website. No. So let's no. So this is all happening. This is a little bit confusing to start with, and then becomes more obvious when you play with it a little bit. But you don't need the Bokeh server to do an awful lot of things and have an awful lot of interactivity. The time when you really sort of get into that is either when you want to run some Python code on the back end, or when you want to stream data, or you have some sort of very data-intensive sort of thing where you can't just throw it all to the browser. But there's an awful lot you can do, and all of these tools and these things are all happening client-side. So I can add another tool here, like box zoom, and now all of my charts in my thing, so now we have box zoom sort of implemented, or I could have actually doing box select would have helped. Let's do box select. And so what this defaults thing does, which is really handy, is it sets up the defaults for your whole notebook. So you don't want to be typing out the same thing over and over again when you're just sort of doing exploratory data analysis. So I've deliberately set my plots kind of short and wide because it makes it easier for you to see. That's probably not going to be true when you're actually working. But let's explore a little bit more. So the magic that I want to show here is all you did was throw a data frame. That's just a pandas data frame. You didn't pass any arguments in. You just threw a data frame into the time series chart, and it sort of just did the right thing. Admittedly, we don't know what those two different lines are, so let's say, yes, I'd like a legend, please. Awesome, now I've got a legend. But hopefully, it's trying to be sometimes too smart, but just smart enough and do the right thing for you. This has only taken 2,000 points because I sort of cut them off at the top here because this is a very long notebook. But you could also, the full glucose set, if you want to run this yourself, the notebooks are available, is 50,000 points, and it'll render just fine in the browser, and it's a very dense plot. We also have horizon plots built in. These are, if you know what they are, they're extremely handy. If you don't, you don't need to use them. But they give you a lot more information density, so they're often used when you have a lot of categories up the left here. As Bryan mentioned, we have a step chart. I decided that I didn't like the red and green, so I've picked a palette here from the palettes that we have built into Bokeh. If I zoom in here now, when you get in really close, you can see how much data we've stacked up there, right? And it's absolutely no problem for Bokeh to handle it. So you can see how this is extremely powerful for your interactions. That's my step function. If I switch it up to the line chart, I'm going to have that smoother. I mean, hopefully this is obvious, but it's obvious what these things are doing. So that's step and line. Let's go back to the car data set. So back to the scatter plot we were looking at before, but now what I did was I said I didn't want to just see the scatter plot of X versus Y. I want to start seeing some categorization, and so I added this new parameter in the color. And one of the things that's really awesome about Bokeh, which sort of made me fall in love with it, is you can power all of your plots with your columns. So at the heart of Bokeh is just column-based data, and so almost anything that's can be a parameter of your plot, you can just pass in a column name, and that column of data will drive your plot. And this makes it extremely powerful to match up your data and your visualization. So here's a box plot. Here's a box plot, like Bryan showed a few box plots before. But what we've done here is we haven't just said I want origin or cylinders along the bottom. We said I want to combine the two together. And so this is showing cylinder 3, origin 3, 4-cylinder origin 1, 4-cylinder origin 2, and so it's just with one line, it's just sort of smushed that data together. So when you don't even know what's in your data, right, and you're just looking at it for the first time, you want to start mashing up different things, looking at their statistical properties, and so there's a sort of a little bit of a learning curve to learn all of the different features that are available to you, but then it should be really fast to start just playing around with your data and having a look. And hopefully this is just giving you an idea. We have the mandatory pie chart, because the further you go up in your organization, the more your managers love a good pie chart, so we didn't want to disappoint anybody. And so I don't know if you learned this morning, but what I've done is I've sort of, there's a little bit of pandas code I've put in the middle there to spit out this pie chart of where the number of cylinders in my data set. So half of my data set is about 4-cylinder cars. Again, another little pandas trick from this morning. I've pulled the make out of this like string. I've turned it into its own column, and I'm going to shove that just throw that into a pie chart, and I can see I have way too many categories here to make a useful pie chart, but that's fine. What else can we do? What else would be? I mean, this is the kind of normal thing you'd be doing when you're looking at a data set for the first time, right? So I'm going to throw it into a bar chart. And what's happened under the hood here is like out of the box, bar has decided to do a count for us because it's like that's probably a sensible default, and so it's counted everything up by the make, which is what we were looking at. But the bars are not in the order I want, and the reason for this is they've been sort of sorted alphabetically on the bottom here, and so that's going to take a little bit of finessing to get it how we want it. So the first thing we do is a little bit of pandas finessing, which, again, this notebook's available, and so if this isn't immediately familiar from the workshop this morning, then it will be soon, but you can just use the simple counts method that comes from pandas, and I made this little mini data frame of all of the counts. So now I'm going to throw that back into Bokeh, and the key thing I've done here is instead of just having the label make, which is what it was like before, I've just done a little bit extra detail in the label option here to make the sort false. And that's meaning that this is not alphabetically sorted now. It's following what my data frame sort was, which means now I get it in the ordered version, so it's how I want to present it. So this is the kind of stuff that you're going to go back and copy and paste a million times over, but hopefully it will give you a sense of the different things you can do. So let's have a look at this. Okay, so now we were looking at counts, and now I want to look at horsepower. And so I threw that into the bar chart, and because I specified the values, I wanted make along the bottom, and I wanted horsepower along the y-axis. What Bokeh's done is it said sum it, but summing all the horsepowers makes absolutely no sense. So, but Bokeh's not actually in sentient inside your computer. We'd love it if it was, but it turns out not so lucky. So what there is there's an aggregate. An aggregation parameter that you can pass to most of these plots, if it makes sense, and so now it's given us the mean, which is probably what we wanted in the case. So we can see that I don't know what a high car is, but it apparently has a lot of horsepower, which maybe it's in the name. So yeah, okay. So a few more. There's the area chart. I've stacked it. I've asked for the legend to see what I want, and so that's almost awesome, but it's done this odd thing of giving us below the zero, which is because that's often a sensible default, but for this particular data, it's not. So the way I would handle that is instead of just wrapping these literally in one-liners, now I might start to break it up a little bit more. And so here I've just made an area chart object, and now I can start playing with it. And I don't know how much you guys have used the notebook. One of the awesome things about it is autocomplete is built in. And so especially when I was starting to learn Bokeh, I just did everything in the notebook, and I just started trying to tab complete things and sort of see what would work. Okay, so Y range, that's what I want to change. And oh, look, there's an end, so there's probably a start. Okay, good. Let's change that to start equals 0. Awesome, now it's where it should be. So one of the things I'd encourage you to do is just to use that sort of attribute part of Bokeh. The other thing that Bokeh does that's sort of not obvious, I'm going to deliberately misspell legend here. You get a horrible error. It's always the way with Python. Don't freak out. One of the really cool things when you scroll to the bottom of this is it's going to try and tell you what you meant to type. So it's saying, I think you meant legend. And you'll be like, yes, I totally did mean legend. And if you really don't know what you meant, I do this all the time. I just like completely misspell something, and again, it's going to complain, and then it's going to tell you all of the things that you could have thrown in, and so then that's another way of sort of, when you're learning something, you've got to have these like tricks to get you going quickly. So that's that. Okay, one more thing to show you. Hopefully you're starting to see some of the power that's sort of under the hood once you learn this. Another sample data set that's in here is the life expectancy data set, which is by country. So this is all of the countries in the world for like 50 years. So I'm just going to pull out the countries beginning with A and like 5-10-year intervals, so we have something we can reason about amongst ourselves for now. So I'm going to use the dot plot. Dot is like a scatter plot, but when you have categorical values, not continuous values. So I'm going to pass in the data frame. I'm going to say I want the 1964 column. I want against the countries, and I've added a label to my axis. And so here it is. So here I can see for the 14 countries in the world beginning with A, here's the life expectancy in 1964. That's nice. But what if I want to see the life expectancy over all of these things? I'm going to use this blend function. And, well, a picture tells 1,000 words. So what you can see is that now I've got 5 dots for every country, and it's 1 dot for each of the columns of data that we had. And so the way I've done this, actually, that's why I set this up. This is hopefully going to explain what blend does. Blend lets you take a bunch of columns, and what were columns, it sort of stacks them together in a how do you say that? It sort of slots them. There must be a proper word for this. It sort of interleaves them all together, right? And so what was 5 columns, 1964, 74, 84, have now become the column year, because that's what I told them to be, which starts with the 1964 data, then there's the 1974 data, and so on, and now it's all sort of in one column. Sorry? Thank you very much. If you can tell, I'm the web developer in the room, not the data scientist. So, and so we made this new column year. And so when we were declaring our plot up here, we defined this blend, and then we said, please color by year. And so because we colored by year, then it was able, just like we'd colored by origin previously, we were able to color by year. So you're going to have a chance to actually do some of this yourself after lunch, but hopefully that's given an overview of kind of the awesomeness of charts. Any questions on that before I go back? Yeah? How hard is it to put a tooltip? Okay. Let's just do one at the top here okay. Live coding, damn it. Okay. So there's basically 2 ways of going about this. I always like to just do it like this. So I'm going to do scatter.add. And again, you can see already that I'm using old habits die hard. I'm using the autocomplete. So I'm going to add the hover tool. And then I always get the syntax. OK, I'm not going to bother. I'm just going to use the non-fancy syntax. And I'm just going to, here you can pick any column that you had in your data set. So I'll just pick name, and you just use @name to use @ and the column sign and the. Did I spell it wrong?
To give it the column label and the field name.
Yeah, but. Okay, that's interesting. That should have worked, and I'm not sure why it's not working out the. Did I break the data set? I might have broken the data. Okay, let's try that again. Okay, so the first thing is I'll just type in a tool type that doesn't do anything, and there it just says hello. What you should be able to do is type @name. Okay, that is, I don't know why that's not working. That should just work out the box like that. And we'll definitely be doing some in the examples after lunch for you to do. But yes, it should just be those 2 lines that you see there.
Crosshairs. You also have another parameter where you have a box which is the values of the crosshair forever.
That may be like a combination of the crosshair and the tool and the hover tool sort of together, but we don't have, I know the sort of thing you mean, and that isn't currently built in.
There's a callback I think you could use for hovering, and so if you want to actually do additional things besides just our hover tool, you can actually have callbacks that can do whatever you want. If you want to update, for instance, some other div in your document with information, or you want to draw your own hover tool, or you want to draw something else, or whatever, the JS callback mechanism is really powerful for adding a lot of kind of interactions to standalone documents that don't require the server, right? So that's one avenue, and so we'll see some examples of those kind of callbacks a bit later.
Okay. So, okay, so that was charts. Very quickly, if you're really getting started and feeling stuck, I think the 2 things that click for me is you're either looking at X and Y when it's some kind of continuous data range, or you're going to be X equals this column, Y equals that column, or you can just throw in the data frame and see what it spits out. If you're in categorical kind of world, it's values on the Y-axis and label on the X-axis, yeah. And so those 2 sort of mental things I put. In terms of the defaults that you maybe want to set up, for your whole notebook that we discussed, pretty much anything you can think of you can set up as a default. So I encourage you to play with that. Becoming a sort of power user, really digging into the attributes, cat, color marker, that I showed a little bit of. The aggregations that I mentioned, these are the aggregations that we have available. Sum, mean, count, number of unique, median, min, max. The data operations like blend and stack, which I showed you, and those kind of the attribute specification, putting together two columns into one. That's the sort of, when you have all that down, you have all of the power of charts at your hand, and if you need more than that, then you're probably going to be working with a different bit of Bokeh. But that should get you very far on your exploratory data analysis. Here's some links to resources about charts, and again, this notebook is available. And so before we move on to plotting, I want to just stress that at the heart of Bokeh is this thing called the column data source. And it's not rocket science, but you should understand it. It's really straightforward. So column data is either going to come in a kind of dictionary form, which, like this is just a pure Python dictionary, or a pandas data frame. And pandas data frames, which you probably covered this morning, you can read in from JSON, from CSV, from Excel, from MySQL, from SQL Alchemy, whatever you can think of, you can read your data into a pandas data frame. So once you can get your data in one of these 2 forms, then you can make yourself a column data source. And so here is the actual data. Like here's what it looks like when we've either taken it from a data frame or from just a pure dictionary and put it into a column data source. It's just a key and then a list of values. And so if your data doesn't look like that, sometimes you might have to think about well, how does Bokeh want to see this? Because at this level, Bokeh is very naive, and that naivety at the data, and we expect the data to all be the same length as well. And so because we have that sort of core assumption, then we can do all these cool and powerful things on top of them and try and do cool, sensible things. So not rocket science, but that's a concept you should know when you're using Bokeh. So let's move on to plotting, which is this one level down. And a lot of the examples that Bryan will show you in the server sort of use this interface. So there's a few more lines of code to make plotting work. At the heart of it, this is going to feel much more matplotlib-y, figure, and this sort of, it used to be even more so, but we've moved away from a little bit of the implicit state kind of thing that matplotlib does. So you're going to set up a figure with some of these things that you might set as defaults on your charts, like your plot width, your plot height, so on. You're going to set that up in Figure. And then you're going to start adding data. And you're going to do that with like p.circle, pass in some x's, pass in some y's. It's not rocket science. And then you're going to show your plot just like you did before in the notebook. This is just passing in lists of data, which is totally fine. We just turn it into a column data source on your behalf under the hood. But you could also set up your own column data source. And you may well want to do this. And then once you've done that, this is going to feel very like the charts interface, where instead of specifying a list of data, I've specified a column name, and I've passed in this column data source. And so this is coming to this idea of driving all of the things with your data. And so I could have a column of x's and a column of y's, but I could also have a column of colors and a column of sizes. And all of a sudden, I'm going to have a bubble plot with lots of colors and lots of lots of different size bubbles, and it's all coming from this data source. And you can also start to add, you don't just have to have circles. You can start to add rectangles and lines and squares and rays, and you can start to, this is where you get this new flexibility, where you can start to build up the custom visualizations, for exactly whatever your needs might be. And the really exciting thing here, which is what I'm sort of hurrying along to, is we're in Python. Everything's just an object that you can start to share amongst itself. And so, this is in the user guide, and this is tiny. That's a bit better. Okay, so here we have our first plot, and we added a circle to it. And here we have a second plot. But in our second plot, when we set it up, we said, I want to use the actual X range that's attached to plot 1. I want to use the actual Y range that's attached to plot 1 in plot 2. And in plot 3, I just want to share the X range from plot 1. And what this has the effect of doing with like really, really simple code is when I'm panning over here, everything is being updated. And so my Y is only being shared amongst 2 plots. My X is being shared amongst all 3. That can be very useful for exploration. Similarly, exactly the same principle, but instead of sharing a range, now I'm going to share a source, the data source. So now that I have lots of plots, but they're all using one data source. And what that means is when I make a selection on one plot, it shows the selection on the other plot. So you could be looking at highly multidimensional data and you're selecting one area, and now you can start to see it highlighted amongst all your things. So you can imagine a grid plot of 12 by 12, and you're starting to, you zoom in and it zooms in on everything. You select a bit and it highlights it in everything. And this is not something that charts can do for you out of the box, because it's going to be very specific to whatever your data is, but with a few extra lines of code, that interaction is really powerful. So that's plotting. The tutorials are fairly plotting heavy, so you're going to get to play a lot with that this afternoon. These are just, because we're short on time this morning, these are just some sort of notes of things to look up in the future. We looked this morning at Output Notebook, which allows bokeh plots to show up in your notebook. I don't know, how many of you work in notebooks actively at the moment? Okay, and so if you push a notebook to GitHub, GitHub will often will render that notebook for you, but it won't render your bokeh plots. So if you want to share a notebook that you've pushed to GitHub, the best place to go and have a look at it is on NBViewer, if you know the site NBViewer. And so you can go and I can show people who are interested in this use case come and ask us about it. But if you share your notebook through a notebook viewer, it will render all your bokeh plots, which means you can share a plot on the web, and anybody that accesses it will have access to all of that interactivity. But coming back to the gentleman down here's question, if it's just client-side interaction, right, just this web browser-side interaction, it's a completely different thing when you're working with the server. So that's Output Notebook. It lets you see your plots in the notebook. Output File, perhaps unsurprisingly, spits your spits your plots out into a standalone web page, which you can share with people. There are also more advanced embedding functions, which let you sort of embed different bokeh plots in like a whole full website. So this is excuse me, I didn't think to get this up ahead of time, but this is a site I built. So these are all bokeh plots, embedded very cleanly inside. And see, hover does work with I don't know why it wasn't working before, but here's hover working in this thing. So this is an example of bokeh being like deeply embedded inside a site, which may be a need for some of you. Resources, again, just something I want to touch on, but there's basically two versions of resources. Resources are the artifacts that Bokeh needs to run. So it's the CSS and the JavaScript that sort of really power Bokeh that you don't see. They can either be inline, which means they're like outputted into your HTML, and they make your web page quite large, but they're there, or they can be from the bokeh.pydata CDN, and that's the default. But there may be some cases where you want to switch to inline. I'm now going to hand over to Bryan to talk about the server.
Great. Yeah, so like I said, all that so far didn't require any Bokeh server, but now I want to talk a little bit about what you can do with the Bokeh server. Again, also part of the Bokeh library on GitHub, BSD licensed, it's ready to go. So what is the Bokeh server really good at, or when might you want to use it? Well, the things it can do for you is it lets you really connect the visualization in the browser to Python code. And so, example we've given is that clustering example where user interactions, selections, or widget interactions drive actual Python code. You want to be able to call out to scikit-learn, right? You can't call out to scikit-learn from JavaScript. Your browser doesn't have scikit-learn, but you can hook up a Bokeh plot that's backed by a Bokeh server, and that server will call scikit-learn and update the plot. And so it's really about having this two-way communication between the Python and the JavaScript, and sort of keeping that up to date transparently and automatically. Other things you can do is you can react to things like range changes. So if you're doing panning and zooming and you want to actually do downsampling on your data, you can do that. We talked about how sort of Datashader is one approach to handling larger data sets, but another one is that you could use a server to create an app that does customized downsampling specifically for your kind of data. And that's definitely possible to do as well. And streaming data is another really good use case for the Bokeh server. So in particular, if you've got data coming from some sensor or from some other data source, maybe you've got financial tick data coming in, you want to be able to drive, maybe you've got just synthetic or synthesized data being created periodically, you can use the streaming API to push data into a Bokeh visualization very efficiently. So there's several examples that are already hosted. If you go to demo.bokehplots.com, I find it, you can see several examples here. And so I'll let you guys can play around with that or take a look at it later. But you can actually click on any of these and see, for instance, any of these running. That's the source code of the actual app. You can go and you can sort of see an example of these running. And here I can choose a different city and whatever. So y'all can check that out. Anyway, so those are the really good use cases for the server. And so quick, very super high-level overview of sort of how the server works. And the basic idea is that the server has this representation of your visualization. It's a collection of objects in Python. And you can actually create those objects from Python, or as mentioned, there's R and Scala bindings. But the server has this collection of Python objects, and then it communicates to the client over WebSocket communication, WebSocket channel. And then it keeps the state in the browser in sync with the live Python objects. And so again, this is very powerful. That means if something in the browser updates, the Python sees that change. And if something in the server Python model updates, it's automatically reflected in the browser. For instance, if a range changes, then the plot will shift over. Or if a user makes a selection, then that selection is available to the Python. And so that's how that's very powerful for people developing these visualizations to let users have a very good experience without having to write a whole lot of code. So again, it tries to keep this in sync and do that automatically for you. So let's go through a quick walkthrough of maybe one example. So that example is actually this one, this sliders example. So if we load that up, it's just plots a little sine wave, and it lets us sort of twiddle the parameters of the sine wave, right? We can sort of move an offset up or down. We can change the amplitude. We can change the phase. We can sort of change the frequency. And the plot updates, we can change my sine wave for strata up here, and it just reacts. And again, all the standard tools are here. We can resize the plot, or we can turn on the wheel zoom tool. None of the tools require the server. Again, all sort plots in the client have that nice tools capability. But what does the code for that look like? So let's take a look, sort of a quick walkthrough of the code and what's required to get this kind of application up and running. The first thing is just some boilerplate. We have some imports from Bokeh, models. We want to get some widgets. We want to get things like a figure. We also want to get the data set up. So here we just create some synthetic sort of data. We create a sine curve. We put it into our column data source. The next thing we want to do is we want to create a figure. Here again, we give some parameters like the size that we want, a title, the number of the tools that we want. We also set some initial ranges. By default, Bokeh tries to use an auto-ranging data range that just automatically sizes, but we actually want to set some fixed ranges here. Quick note at the bottom, there is some stuff that we're going to be cleaning up in a future release very soon, but in this case, I've used figure with a capital F, and that's because I'm actually going to be putting this figure into a more complex layout, and I'll talk a bit about some Bokeh wisdom about that a little bit later, but just note here I've used that sort of capital F figure. The next thing is we want to set up the widgets that we saw. And this is very easy, right? So we have some text inputs at the top, and we have some 4 sliders, right? And so all of those are here. So we have a slider for the offset, the amplitude, the phase, the frequency. We give it the standard parameters you would expect, the start point and end point, a label. Excuse me. And so it's very easy to declare those just in a standard Python script, right? So this is all just a standard Python script. There's no sort of classes you have to define or special things you have to do. This is just a Python script with some lines of code. We create those. And then we actually want to set up some handlers. What happens when those sliders get scrubbed or those widgets change? We actually want to say what happens by defining these callbacks, right? So here we've got an update title, which says if the title in the text box changes, then I want to set the plot title according to that text box. And then I attach it with that text.onChange. We've got an update data. So if the data, if one of the sliders changes, it calls this update data, and it pulls off all the values from the sliders, recomputes the curve, and then that's what causes the excuse me, that's what causes the plot to update. Again, we have this nice mirror between the Python, between the JavaScript. So if we change the data on the Python side in the server, the plot automatically responds and updates as well. Finally, we just create a layout, and we add it to our document. So here, we've got this VBox. We're going to be putting all of our sliders in this VBox. We're going to make another sort of horizontal box that has the sliders and the plot. We add that to our document, and then we're done. And that's all the code to have that, that web app that you can run. And we can run that very simply with the Bokeh serve command. I'm just going to show that right quick. So here, if I go Bokeh serve -- show sliders .py, that will just come up. And so now I've run it locally. And so there's all kinds of options. There are more sophisticated options if you need to actually deploy this. So I mean, if you're just experimenting locally, you want to create an app to play around with, maybe a model, drive some scikit-learn or scikit-image or other PyData tools. It's great, super easy to do. But if you want to deploy these to a wider audience, that's definitely possible too. And so the excuse me, the user's guide has a lot of information about how to deploy to sort of a wider, more public audience. Question? Excuse me. Yes, there's a tap tool, and you can add both the JavaScript callback to that, but you can also get the tap information in the server as well. Okay. So there actually are not very many. The question was about the dependencies for Bokeh and the Bokeh server. The new Bokeh server is built on Tornado, and that's pretty much the main dependency, is uses Tornado. Beyond that, there's not very many dependencies, runtime dependencies for Bokeh. Pandas is an optional dependency for Bokeh.charts. There's other dependencies. NumPy is used. But there's only the list of dependencies, I think, is 6 or 7. We've tried to pare it down greatly over the years, and so, but the main dependency for the server is Tornado. And on Python 2, you also need concurrent.futures on Python 2.7 if you're using Python 2. But that's built into Python 3, so yeah. Other question? There's a lot of different ways. Yeah. So the question is about what to do when you have large data. So like I said, there's really actually a lot of different options. So it's hard to give sort of a very completely generic or response to that question. One is that you can do downsampling yourself, on however you want in the Bokeh server. So the Bokeh server lets you hook up these callbacks that happen in response to events, and so you can run arbitrary Python code there. So if you can do whatever you want to downsample your data appropriately and efficiently, given whatever trade-offs you have in terms of your hardware and your data and where it's stored. We also have the Datashader library, which is, again, a separate sort of project under the Bokeh sort of umbrella, Bokeh organization. And that, again, really depends on your resources, right? So that 3 billion point, that OpenStreetMap, in a webinar recently, Jim, the project lead for that, was talking about how he made a point to do it both on his laptop, where there's not enough RAM to actually hold all the data in memory, and it took several minutes to do, doing out-of-core computations. But doing it, he also provisioned some cloud compute that had enough RAM to actually hold the whole data set in memory, and in that it took like 7 seconds, I think, to run through and actually render that full data set. So it really depends sort of on your situation. It's hard to give concrete advice without sort of digging into the details. But what we're really trying to provide is like options and capability, right? And make it a platform that gives you different ways that you could go depending on what you actually have for your situation. Okay. Yeah, question?
So on those really large data sets, so you only work on patterns, you don't work on data frames?
So no, it's completely agnostic. So the server, again, runs arbitrary code. So for instance, some of the Datashader examples are backed by Castra, is what they've chosen to use. But in principle, you could connect to Redis or whatever backend database you'd like. Because again, your Bokeh server application is written in Python, and so that's sort of the power of it, is whatever's available in the PyData stack for interacting with data, you can use those tools to pull data in and get them into the browser. So again, when you talk about big data sets, you're either talking about using Datashader, sort of try to automatically handle rasterizing very large data sets, or you're talking about implementing your own sort of downsampling technique using those PyData tools. So you could use Pandas, you could use NumPy, you could use other tools. If you have a database that can automatically do downsampling, if you query it appropriately, you could just query the database and get back the downsampled data that you want, and then send that on, based on, for instance, the range. So,
if I can make one point that may not be obvious, don't send 3 billion points to the browser, right? Your browser will explode. So if you start sending more than 100,000 points locally, or 10,000 points over the full internet, everything's going to slow down.
Yeah.
So that's you're always going to be sending a subset of data, and what's going back and forth is that column data source. It's a list of a dictionary of lists. So as long as you can think about it like that.
yeah.
Yes.
Yes. Yeah, so the streaming API, we want to add more features to it, but the basic streaming API right now, you can specify what's the incremental new data, so that you don't have to send all the data every time, of course. But then also you can give an optional rollover. So if you say, I want to drop off data, I want to have a buffer of this size, it'll start dropping off the earlier data. So we do want to continue adding features to the streaming API and build it out to be more featureful, but that's what it supports right now. Cool. Good questions. All right. Couple of last slides here, just about some wisdom. If you do try the server out, there's a couple of things that are useful to know that maybe aren't right now in the docs, at least as prominently as they could be, and so I'm trying to collect this sort of wisdom. One is that when you're updating the data, you always want to try to update all the data at once. And so the column data sources have this .data attribute, which is basically this dictionary of named columns. What you want to do is set the entire sort of .data attribute at once. And the reason for this is because if you set them separately, as is done in that sort of second version, while you update the x, that triggers an update in the plot, which updates the x values of the points, but not the y values. And then you update the y, and that updates the y values. So you actually get sort of unpleasant. You can get unpleasant sort of flickering because things aren't updating simultaneously. And any change you make in the Python gets automatically reflected, and so that's good. But it also has consequences like this. So in this case, you want to try to update all the data at once. Another thing, session cleanup, especially if you're running a sort of a deployed application that's using periodic callbacks, you want to make sure to use some of these options here for sort of auto cleaning up sessions. Right, by default, Bokeh doesn't sort of clean up. If you just run it locally, you start it and you stop it, and you're just sort of playing around with things. But if you're actually doing a real deployment, as described sort of in the user's guide, you want to tell it, I want you to check for unused sessions with this frequency and clean up anything that's older than this. Embedding as well. If you want to embed these kind of applications in another website, you can definitely do that. There's another bokeh.embed.autoload server. You give it basically the URL to the server and the app path on that server, and it will give you back a script that will embed that application in your site. So for instance, if you have a blog site and you want to embed a Bokeh app in that blog site, that's fine, but you do need to, when you run the server, when you deploy things, you need to configure it to let that blog site make this WebSocket connection. So there's this allow WebSocket origin option that you're going to want to add. So this is really only useful for that embedding case. If you're just running things locally, that's fine. If you're just running things behind Nginx or something deployed and you're not embedding, that's also fine. But again, it's specifically this autoload server embedding case. Okay, last thing here, I mentioned there's a little bit of clunkiness in the API we're going to be fixing up very shortly. There's sort of some things where you've got this sort of lowercase figure and capital figure, and then there's also some things like hplot and bplot that are lowercase, and hbox and vbox. And the basic difference, the rule to remember, is that the lowercase ones try to do some extra work automatically. Going back to sort of the beginnings of Bokeh, there was a lot of attempt to sort of mirror some of the implicit behavior that some other libraries have, and so that's good and that's bad. We've sort of moved away from a lot of that implicitness, and some of this is just left over from that. But typically, if you're making something that has a more complicated layout, like you've got rows and columns and several plots or several widgets, you'll want to use those capital letter versions, capital F figure, and it won't do that automatic work for you. Okay. Okay. Last thing, I just wanted to show a few things about Datashader. Excuse me. So Datashader is really a pipeline. Actually, originally, we tried to sort of make it built into Bokeh, and we realized that it's sort of quite separable and better for both projects if they're sort of developed at their own paces, and it's worked out really well. Lately, there's been a lot of active development on Datashader. So what it tries to do is it tries to break up this rendering pipeline or rendering process into sort of three distinct steps. One is projection. We want to specify some shape or glyph, and we want to sort of look at where our data, and if we imagine tiling some sort of abstract plane with this glyph, where does our data fall in if we sort of project it according to that glyph? And then we want to aggregate in each of those projected areas. And so the nice thing about these two steps is that they're very parallelizable, right? So we can use things like Dask, or we can use other tools to sort of do a lot of this computation in parallel. Fast, and the result is this aggregation that's much smaller. It's on the order of an image that's on the order of something you can send to your browser. And so with this aggregates, though, you can still do lots of transformations and ask lots of questions. But now the benefit is that though you can ask those questions very quickly, right? Transformations on the aggregates are actually very quick. Here's just maybe another sort of very, very high level look as we start off with some data. We have some synthesized sort of scene graph, and then we sort of imagine, in this case, tiling our an abstract sort of grid, and we want to project into that grid. It's really just a rasterization process, sort of a pre-rasterization process, but it's very flexible, and then it allows us to insert all these transformations at the end. So there's some pre-executed notebooks you can actually take a look. Let me go ahead and go here. There's quite a few. Some of the ones that I've already shown you. This one in particular is that OpenStreetMap one. And so there's actually quite a lot of detail. Jim writes these really nice narrative textbook notebooks that talk a lot about exactly what's going on and some of the details. But again, this was that full 3 billion point OSM data set. We have some interesting results about sort of the performance that, how that was done using Dask. So again, on his 16 gigabyte machine, the data doesn't actually fit in memory, and so there was a lot of time spent using disk reads. And so you can actually see, in this profile, there's actually a lot of reads that show up. But he did go ahead and run this on a full, the 54 gig data set on a machine that had enough RAM, and it was actually very, very fast to do so. So that's one of the ones that's there. If we go back, the New York City taxi is there. The census data one is pretty interesting. So this is the, I'll load this one up. This is the full 300 million point data set, or US Census data. What's interesting about this is that it's tagged with a categorical category. So this is actually tagged by race. And so what Datashader allows you to do, well, one, the main problem that Datashader is trying to let you solve is what happens when you have 300 million points. If you just plot them all, they just plot on top of one another, and you lose all detail, right? You can't tell, you oversaturate the plot. And so you can try, toggling alpha values, and maybe that helps a little bit with overplotting. But eventually, with so many points, even that doesn't help, and you still lose sort of dynamic range in your data. So basically, this data shading pipeline gives you a lot of power over how exactly you want to do this mapping and do this transformations. In this case, we've switched from using a linear mapping, which loses a lot of detail, to now a log mapping. And we can see that this kind of log mapping allows us to get much more sort of detailed information, but you can try other ones as well. Here we actually do a histogram equalization. And once you do sort of this kind of transform, which is easy to spell in Datashader, you can see lots of additional structure. You can sort of see cities occurring at crossroads, and you can sort of see the structure of the population as governed by the topography and the geography as well. You can also specify different color maps. All of our things here. Here's the nice Viridis color map that was recently added to matplotlib. And the main thing here is you can also use it to tag things by categorical value, and you can combine those in a meaningful way. And so here, I don't have this app running here, but we'll be showing it off. If you come by the booth at Strata, I think we'll have this running where you can zoom in and you can get this interactive progressive refinement, and you can sort of get to detail. Here, if I start zooming into Chicago, we can sort of see a lot of the segregation along different geographic boundaries in Chicago. And if you keep zooming in, you eventually start to see the individual data points, right? These have all been anonymized within the block level the source data set has, but the point is that you can have this interactivity where you can zoom in all the way out from the full US data set all the way down to the individual measurements there. Okay.
It's lunchtime.
It's lunchtime, I think. So I think we'll put up one more slide here. So this is what we've sort of shown a quick high-level overview map of Bokeh. We'll leave this slide up for the afternoon if you do want to sort of follow along and do some exercises. There's a series of notebooks for the tutorial that are linked from that link there, and just some other information about the mailing list and doc. So we'll see everyone in about an hour. Thanks, everyone. Oh, if you go to that link, so yeah, I guess you have to type it in. But it's in the Bokeh notebooks. There's this tutorial. There's a README here. Let me actually bring up the README as well. Where it says whatever you need to do to install. I have too many tabs
so
open.
The top link on that slide is everything we've shown you this morning, and the bottom link is so it's all the notebooks you've just seen, all of the links, everything you've just seen is available there, and then the bottom link is everything you need for this afternoon, and we can help you over lunchtime.
Yeah, absolutely. If anyone has any questions, I'll leave this up here as well, so you can install with pip or with Conda. And then there's some sample data to get, but we'll go over.
The first one back.
Yeah. Here you go. I'll leave that one up. That's got the link, and you can follow the link, and that has that README with that information.